Guys, the session was out actually, so I am reconnecting. Okay, then, so it's recording. I forget recording, that is why I'm checking back if it is honest, where is my browser? Share, okay, where do I have, yeah, here. I think this is, yeah. This time what I just copy this. I already have the path with me, so copy the path, paste it here, and I think this should be cross tab, right? Yeah, cross tab CSV. When I press tab, it came automatically. Now when I press enter, it is silent, which means it could, now data, you see I have gender and, so this is how your data looks like. You will not be, admit, oh my God. Okay. Now how are you going to do? In pandas, we have a method called cross tab. Okay, so we can make use of that. We say data cross. Now PD, we already have PD. Cross tab, I guess. Yeah, cross tab. Now data. So the first one is gender, right? And then data. Second column is tab. I think there is nothing wrong here. Yeah, it is silent. Data cross. Yeah. Now I see you got the cross tab. Very beautiful cross tab. I think unfortunately we got this is very small. I mean, the frequencies are not such a big numbers sufficient enough to perform the chi-square analysis. This is not, this table is not suitable for chi-square analysis. We need to have the cell. I mean, sufficient sample for, because chi-square analysis is always a robust statistical test, which means it needs larger samples. It is Z square. I already told you it is a, when you square normal variate, then you get chi-square statistic. That way, chi-square analysis or test always requires sufficient amount of, usually sample greater than 30 can be better. In my, there are observations where people says mostly this, that is why we have chi-square test as a default test in most of the multivariate statistical analysis, where you tend to have a very bigger sample size, which means your n size is going to be more than or equal, I mean, greater than or equal to 200, 300, or at least 100, 150. But in my opinion, any sample, I mean, as per science, one of the benchmarks in statistical theory is that any sample which goes beyond 30, if the sample size is greater than 30, then that is marginally large sample, something like that. It is a large sample, which will be inconsistent with all the properties of normality theory. So you should have the end of the, I mean, the end of the day, the rule is that you should have some normal distribution in your hand. So now how are you going to perform the chi-square analysis on this table? Same, I think for table, we have the same for chi-square tables, yes, correct. I don't know if I can make use of this. We are using, what is that? Chi-square. But this is not the, we'll try to use the same command and see if we can do stats, chi-square, okay, and then data underscore cross. Now let's see what's going to happen. Oh my God. So you got, you know, 0, 0, 0, 1, and you got 1, 2, 3, 4, 5, and then p values 1, 2. So this is not appropriate, you see? So this is not the way we go. So for each cell, I mean, there is a chi-square statistic for each of the values in the crosstab. each cell has got a chi-square statistic along with a p-value. Well, that is not the way. We need to have one single chi-square value along with a p-value. But anyway, I'm happy that I could perform chi-square analysis over this crosstab, but that's not the way. So in stats, you have a function called chi-square underscore contingency, because this is a contingency table. It is not a uni or bivariate distribution. It is a crosstab, a contingency table. Contingency means in literally, I mean in English, contingent in the sense one that depends on other kind of thing. So now, the interest of this analysis, I mean, till now the interest was to test the fitness of the distribution, but now whenever you have contingency table in your hand, you are going to test the hypothesis that one variable is not going to depend on the other variable, or the variables under study are independent from each other. That is what is the H naught here is going to be the variables under study are independent. Okay, independent. Now let me make markdown and then I press enter. You see, this is null hypothesis. Obviously, the alternative hypothesis is going to be dependent, something like that. Now, how are you going to do that? Here, what we need to do is first we perform the analysis. Stats. You see, I just write CHI and press tab. Let's see what's going to happen. So this is what is the function I'm talking about. Till now we use the chi-square, but now we are using chi-square contingency because that is the appropriate function. Because we have contingency table instead of a tabular, the columnar data. Now data underscore cross. Let me press, yeah. See, this time you want a chi-square value, a p-value, and degrees of freedom, and an array. And do you know what is this array? These are expected frequencies. For each of these actual observations, what is the expected observation for this cell value? What is the 1.06 is going to be the expected value for this one. This value, if you imagine that this crosstab is distributed as chi-square distribution, then we would expect to see these values instead of these values. That is what is the meaning. So we'll not be having 1 here, but we'll be having 1.06. Actually, as per the chi-square theory, so we need to have 1.066 instead of 1 here, and we need to have 1.0. So 0.933 here, not 1.06. So this is actually the 1, 2, 3, 4, 1, 2, 3, 4, and last one is the 5, the 1.6 and 1.4. Now you got the chi-square value, you got the p-value. You see here the p-value is greater than 0.05. So since the p-value is greater than 0.05, we cannot reject null hypothesis, which means the variables under study are independent. So we cannot take decision. We can't take decisions related to salary based on gender. So intergender differences to salary are negligible. So we can't say that the salaries are biased with respect to gender, which means male has more salary and female has more salary. You see here actually the female has more salary compared to male. As far as 60 to 80 is concerned, there are 3 individuals who are female whose salary is 60 to 80, but is that difference? See, till here there are no differences between male and female, but here there is a little difference. And there is also difference here as far as 80 and above. 80 and above, there are 2 males, there is only 1. But are these differences statistically significant? So since till here there isn't any difference, but here there is very little difference as far as the last 2 categories are concerned. But these differences, are they statistically significant to state that the salary does not depend on gender? Now here the difference is not statistically significant, so which means they are independent of each other. So we can't understand salary based on gender in this sample data. Okay, I'm not talking of in this. I just simulated sample this data. Okay, but you are going to have the I just wanted to show you how to import the data sets into your session, just like this. I mean, only to mimic as if we have real-time data, and then how to perform the Chisquare analysis. So this way, you can just, so now in this session, I mean, till now, I explained you how to import the packages and how to simulate data sets and test yourself, test a Chisquare analysis yourself, and then how to import the data sets using pandas, and then perform on both numerical data distributions as well as categorical data distributions. So this way you can perform the Chisquare analysis. I think that is, yeah, this is, let me, I think the section is getting recorded, and Chisquare is your document. I'm just saving this section. Okay, any questions related to Chisquare analysis? If you don't have the questions, then I thoroughly go to the other. There are many things you can perform. This Chi-square, I just only explained you two ways of performing Chi-square analysis, which means on numerical data and as well as categorical data. But there are a lot of issues in Chi-square analysis. I mean, not issues, variety of ways to perform the Chi-square analysis. If you go to contingency tables, okay, I'll just take you to the topic called contingency tables. I think you should be able to see my, browser, contingency tables. Okay, you have so many things. Okay, but all of them, I will just leave that discussion to you. You spend some time and try to read contingency tables. Contingency tables or contingency test, I don't know. I don't remember exactly what is this. But there are so many statistics. You see here, you have phi coefficient. They're all alternative statistics. I mean, they're all actually the different varieties of chi-square test. Phi coefficient is a chi-square test performed on 2x2 contingency table. Suppose if you have a crosstab with dichotomous responses, just like yes or no, male or female kind of things. So you'll be having 2x2 crosstab. Then you have phi. But here you don't have enough information. Along with phi, you also have Yule's cube. That is not there in this Wikipedia, but you can find what is Yule's cube, something like that. What is it ready? Zoom is telling me something is ready. I don't know what is that ready. Your Zoom is ready. Okay. Now you got Cramer's V and Cramer's C. They're also alternative. I mean, they're all different tests related to chi-square. They depend on chi-square statistics. What is this? Zoom is ready. Zoom is ready. It's giving me some path raised a hand. Where are you, path? You raised a hand. I'm not able to see hand. Yeah. Hey, Path gave me a private message. I'm sorry, Path, to be open. Yeah, I asked a question. Okay. Now it came public. Okay, Path, good. I appreciate you. Increase the data set size. Increase the data set size. Yeah, we can increase, but you don't do it. I mean, I can do that, but let me go ahead with, you can increase the data set size and test, do chi-square analysis and see how you can do a lot of experiments. Does it also consider correlation? What is the, no, it is not. Chi-square analysis is not a correlation, but you can convert the chi-square statistic into Pearson or coefficient. There are methods. Especially there is a test called CMH, Cochrane Mantel-Hangel test, which is actually picks up the chi-square statistic and it converts that into Pearson or. That is called linear by linear association. If you perform chi-square analysis in SPSS, you are going to have 4 5 statistics, one just below the other. First one is chi-square statistic, next linear by linear association, and then you have kind of likelihood ratio. You have a test called G-test. It is actually a likelihood maximum likelihood ratio, unbiased best estimate. You call unbiased best linear estimate, something like that. Blue, best linear estimate, something like that. Best linear unbiased estimate, that is blue. So G-test performs that. That is what I'm saying. There are hundreds of hundred ways of performing the chi-square test based on the type of the data that you have in your hand. Yeah, if the correlation is zero, then there is no correlation between variables. Yes, but we are not testing correlation here. We are testing dependency. Whenever you are performing chi-square test, you perform a test for dependency, not for the association. So you have to convert the chi-square statistic into the corresponding R value. Then only it is possible for you to compute the uh, talk about the association, or maybe you can talk relationship, but you cannot just talk about association by merely performing chi-square analysis. That is not correct. Any other question? You keep your, I mean, you can ask me questions, but we are running out of time, and I have so many things. Any other important question? Don't afraid, please. I think I'm not scaring you. You're not scared of me. I'm sure you're not scared of me, none of you. But at the same time, I'm like this Kramer V and Kramer C is there, and there are other, like here you see gamma test. This is Goodman Kruskal gamma. You can calculate gamma based on chi-square statistic. You can calculate tau, Kendall's tau based on chi-square statistic. There are two varieties of tau B, tau C with ties and untied information. You have ties, you have C, you have untied data, you have B, something like that. And apart from that, you have so many others. McNemar test of association. Not association, it is actually, um, I think McNemar test is done for odds ratio. This is actually jargon of the chi-square analysis. Odds ratio, risk ratio, homogeneity. There are ways to test the homogeneity. There are ways to test the similarity. This is what we are. Art is asking me the questions related to correlation. So if the correlation is your interest, then you have quite a bit of analysis to perform. That I'm not touching it in my lecture. I mean, I don't think I will be able to talk about, finding similarities or correlations using chi-square analysis. That if I have time, I may go for that. Okay. Now, let me thoroughly go to the t-test, which is another. See now, why did I teach you chi-square analysis? Because most of the time in your data set, you will be having categorical data. So whenever you have non-parametric, I mean, if your underlying distribution, if you're not able to prove that your data variables are normally distributed, I mean, you have to perform the normal distribution, normal test, normality test. Generally, you can say the distribution is not normally. If you don't have non-normally distributed data in your hand, and most of the data is categorical. I mean, in social sciences, what happens is that whenever we, I mean, mostly we employ some non-parametric data. I mean, we accommodate non-parametric data in our data set. The questions, the way we ask the questions, we go to the respondents, ask the questions, and when we take the answers into the data, most of those responses are non-parametric. So given such a, if you are in some certain situation, then you have to perform the correlation. You might be in requirement of the correlation analysis. So you should not feel that we did not discuss correlation analysis in our class. That is why I have been talking about correlation analysis using Python. Okay. So now you have a t-test. So why I'm talking t-test once again, you may be having you see numerical data. Yeah, you will be having mostly, I mean, I do see whenever I give assignments to the students, they come back and tell me that, sir, I have all, unscaled data. You don't have, actually, our design, you need to have some strategy in your brain when, before you go for the data collection. We have very poor data collection strategies. Most of us, most of us in the sense like most of the students, most of the time students, whenever they go for the correction, I don't know where the problems. They may not either properly contact, properly in communication with their guides. So they come back and show all, useless data with all undesigned scheme in their brain. Is there non-categorical data? Yes, non-categorical data is there. Whenever you have numerical, which is not ratio, and interval data is non-categorical. Like you have salary, time, you have age. They're all non-categorical. Later, we convert them into categories. It is always advisable to collect data as non-categorical ratio, because any moment you can convert that data into categorical. But if you have categories, it is very difficult to convert that data, because ratio and interval are superior data, superior measurement schemes. And nominal and ordinal, they are, I don't say they are inferior, but you can't do there. You'll not be having much scope for analysis. Yeah, yeah, we no, not non-categorical. You convert that into categorical. That is opposite of the thought process. If you have to convert the data, mostly, wherever it is. Suppose if you go for the satisfaction. Now what happens? It is scaled. You have to choose a scale. It is categorical. It is categorical, but scale. You will be having some rank-based scales, or rating scale, or kind of there are inverse scale. There are so many types of scales. Okay, you just can search for. You must have some strategy in your brain. How should I collect the data from it? In business research, you have a particular topic called attitude measurement. Attitude measurements we specifically teach to the students in order to get them understand that they're all behavioral traits. Attitude is a behavioral trait, which you cannot be, you can't just ask a candidate like, what is your behavior? That is a foolish question. So a researcher must have a design in his brain to measure the attitude of the individual. So if you straight away go to a patient and ask, like, what is your attitude? It is a meaningless question. No patient say I have negative attitude. Okay, no patient will be willing to say that, I'm indifferent or something. No, you don't find such a honest people in the field. So researcher must have some design in his or her brain, such a way that they just glean information from the candidates without asking them direct questions. Are you good or bad? Everybody say, I say I'm good. Why should I say bad? So asking, isn't your behavior good or bad? That's obviously a foolish question. So you cannot have such a design in your research. So you need to have a strategy. So what I'm trying to tell you, whenever you, not you actually, whenever in research, in general, we need to have a design. We need to have a strategy. Well, before this, nobody will talk to you. I spoke all these things for 15 years, and today, nowadays, I'm not talking about business research methods. Actually, you need all those, lessons. But maybe some other teachers, I'm bored of talking all those things. Okay, if you don't have enough questions, then convert to non-continuous. I don't know. There's a question, but wrote it in reverse. I don't understand what is it. Wrote it in reverse. Okay. Now let me thoroughly. I without much further discussion on. I don't like to spend further time, little more time on questions. I straight away go to the t-test. Now, if you, so when I'm talking about the t-test, please be informed that we are talking about the parametric test. Now we are under the hood of the normality test. Okay. So if is there anybody who don't know what is the t-test, then you just have to go to t-test. It's called student's t-test. Okay. There was a man who has who is the inventor of this, who discovered this test, or invented this test, known as t-test. It was student t-test. He had introduced this test based on his pen name called student. Okay, then you will find this is just a simple calculation. You don't need to. This is just x bar minus mu divided by standard error of mean. So if you divide the difference between the sample mean to that of, the difference between the sample mean to the mu is a assumed mean, or maybe hypothetical mean, and divided by standard error. What is the standard error? Standard deviation divided by square root of n. So you have to know all these formulas. Now, I know, but you have to know. If you're doing t-test without knowing this calculation is a foolish activity. So as a student, it is your duty to know what is t-test and under what circumstances we perform the t-test and where are all. So in our data, let us go back to see here. We have, this is categorical data. You can perform t-test on categorical data, but you need to convert that into numerical data. So all male, female, 1, 2, 1, 2, 1, 2, and all. I don't suggest, because just now we performed Chisquare test on this data. So performing t-test is a foolish activity. So I don't want to do that. What I try to do, I think we already have some data. This is continuous data, right? That distribution 1 and distribution 2 here. So this is good for, this is a ratio based data, ratio scale. The distribution 1 and distribution 2. Here we can perform the t-test. Now to perform the t-test in stats, same stats module, you got different types of tests. One of the tests is t-test one sample. There are 3 types of tests. Okay, I write it here. There are 3 types of t-test. I think I should write it like this, t-test. I think my session is going to be closed. After this, I will not reconnect once again. Once the session closes, then it is closed for the day. T-test, first one is one sample t-test, and then second one is independent sample. This is, I'm just telling you, you have to study all this. Independent sample t-test. So most of the time we don't encounter these scenarios. Okay, you don't. And paid sample t-test. Paid sample t-test. So there is a lot of theory. So each one of them are different. This is one sample t-test, which means you need to have, in this procedure, as per the theory, you need to have a hypothetical mean or assumed mean. You will be testing the sample mean against a hypothetical mean, which is mu. Independent sample t-test, you have 2 different samples with same criteria. Say, for example, you have age particulars of a sample 1 and age particulars of a sample 2. Age particulars and the salary details of a sample 1, salary details of satisfaction of sample 1, satisfaction of sample 2. And these 2 samples are different from each other, but they fall under same criteria. Maybe they belong to same firm, or maybe they belong to same department, or maybe they belong to same region, or maybe they belong to some, they must have some kind of binding parameter. You cannot just take age particulars of some species and the age particulars of some other species, and you cannot do a t-test or something like that. I don't know. If that is your study interest, you can go ahead. And there is a paid sample t-test, which means you have only one single sample, but you are measuring at 2 different times, and you have sample 1 and sample 2. They are paid. They are paid by the individuals. It may not be based on the sample individuals. It may be based on 2 different individuals, but the same criteria. Okay, 2 different individuals, the same criteria is independent sample t-test, but the same individuals with same criteria at 2 different times is the paid sample t-test. Now, why do we need to have these many types of t-test? This t-test is actually falls under a particular group of techniques called mean difference tests. There is also a test for median. That is actually Mann-Whitney-Wilcoxon. I think it is a Wilcoxon test. If you take the median, and because that is a non-model value, when you use mean, it is obviously a t-test. Okay, and parametric, which means your underlying distribution should be a normal distribution. T distribution is bell-shaped symmetric curve, just like once again, the normality test for small samples is t-test. Normality test for bigger samples is z-test, which means that jet test. Okay, that is in Python you have stats, same stats we are going to use. Now here what I do, I just try to simulate datasets, stats, norm. In stats you got norm or VS, random variable, simulate. Now I have only 10 minutes of time. I just thoroughly do this. Location, I don't need to give, okay. For your understanding, I just try to write the location. Scale is equal to 1. Okay, location is 0. Scale is 0. I want to see that this distribution is a Pakka normal distribution. Now size 50 or let's say 30 because we are going for t-test, right? We cannot have 50. A small sample should be always less than or equal to 30. Now you got this size, scale is 1 and size, yeah, I did a mistake here. Size is 30. So now I got RVS, shift, enter, and pressing enter. Now you see array. This is a simple array, and now length of RVS random. I internally simulated data set from the normal distribution. You see here, and this is a Pakka normal distribution. Now we should see if the mean value is significantly different from 0. So what is the mean value for the perfect normal distribution? 0. What is the mean standard deviation for the perfect normal distribution? 1. So that is why there is a design behind my thought process. Now let's go for the t-test, stats, and then t-test. You see, you will get a lot of t-test one sample, t-test independent, t-test independent from stats. This is just a wrapper for me. I mean, I don't want, there's an extra test for it. T-test rel, which is actually reverse t-test. There is a procedure called, I think if you have data like this, in Python what happens, you can transpose the data and make it as a column and do it, but you can do it without transposing this. That is called rel. First we'll go for the sample, one sample t-test. Now the data is going to be RVS, and let us press this, shift enter, and let's see what's going to happen. Now, yeah, one missing position. So we have to give the assured mean. I'm going to give 0, 0.0, I guess. Now let's put 0 and say, yeah, okay. I think mostly we are in Python, especially in statistics and stats module, we'll use the float data. This is actually the way we perform. Now we see you got the t statistic. It is upper tail distribution, I guess. You see 0.25, which is positive. And now p-value is 0.79. So which means the mean value of this distribution is not statistically different from 0, which means it's a Pakka normal distribution. So alternatively, in other words, we are trying to test the normality of the distribution. So we simulated data from the normal distribution. Why I'm doing this? I'm doing it internally to show you that suppose if you have a normal distribution under study, then how are you going to test? So we want to test the mean value of this distribution. This normal, we know that this is a normal distribution. So knowingly we are performing this test. Again, we are comparing the mean value of this with 0, and yes, it is. You see 0.794. So whatever that the difference, it is 79% likely that we get this type of data under normal distribution. That is what is the definition. So it is more than 50% or close to, or it is 79% likely that this data can be distributed under T distribution, which is a normal distribution. We distribute it is possible for us to get this type of data under T distribution, and the probability is the evidence is 79%. So that's how you can take the decision, or you can just you don't need to. You have other way. Since this is another, since the p-value is greater than 0.05, we fail to reject null hypothesis, which means what is the null hypothesis? That is H naught is X bar. Now I'll put, because we are in Markdown, right? In Markdown, I don't know. I think I can just go for bar. I don't. Can I use this? X bar is equal to mu. I don't know. I'm just trying to do this. Yeah, x bar is equal to mu. That is how in Markdown you can just use LaTeX formulas in Markdown. This is a LaTeX code. So when you press x bar is equal to, this is null hypothesis. Okay. Yeah, I think you can also use that is, can I use break? Sometimes it happens. It accepts. Yeah. So you see now breaken. The HTML is also working. That's fine. Good. Hmm? Okay, that's fine. Good. Now, so that is a null hypothesis. We failed to reject this null hypothesis that x bar is equal. Yes, x bar is equal. The mean value of this distribution is close to 0. This is one sample t-test, and for two sample t-test, we got t independent kind of thing. Let's yes. So where is that? Yeah. Now what we tried. Yeah. Let me do this same test on our datasets. What is our dataset? It's the data. First one, I think list one. I have to do data list one. Stats. So now I think I think I have to put it here. Separate from here. Insert above. No, I'll put H3. One sample t test. Now it is going to be all marked down. Now guys, it is going to close. I think my time is clicking. Anytime it may close, and once it closes, the session is over for the day. Now we'll go for the data. So stats, now two sample t-test. H3, now two independent sample t-test. I will change it into markdown and then press enter. Now yes, data. Let's go for, I want to hurry. T-test, right? And then independent. Now, I think here I have to write everything. Independent data, and now dist. Yeah, independent, you need to have two different. So we can just leave this. When you press one is position argument B, yeah, that is not okay. So it is asking me this one, and then data list 2. Here there's a lot of big pandas. It is a pandas. This one here. This one. It's not this one. What's the name of the dist dist one dist one? Then what is the problem? Here pandas with t-test element. Is it correct? T-test element. I think it is correct. Now data dist one. Let me here insert another cell above and say head data list one and then head. Why? There's no data. Why I don't have data? Cell camera cell run all. One sample, two sample just here it should be. Why I don't have? Is it not data? Data head. Yes, I have data head here. Data. I think, yeah, here I changed it. That is why we should always use data 2. It's going on differently. Right, data cell run all. Again, there is stats, and there's a problem here. Data. This data is there. Chi-square data history. Chi-square. This should be one sample, no? No. Why one sample? It can be two samples. No, here it's coming here. 3D reads here, 3 period data frame.